This is UCL News.
Good evening, ladies and gentlemen. This is a special edition of UCL News here with Bertrand Stonehole and Julien Gillet. Today, over 300,000 people came in Brussels for all the corners of Europe to protest against our actual consumer society and to claim a better use of green energy. Our reporters are on the spot.
Now let's join our reporters. What's the situation there in Brussels?
There is a big demonstration. People are angry because of the energy cost. Pollution has made life very difficult. I'm standing here with a demonstrator. What would you like to say?
The cost of energy is too expensive. I have heard about a mysterious energy fallen from the sky. We need to use it, but I don't know anything about it.
Okay, thanks. Back to studio now.
Thank you. We've just seen what's the situation at the moment, but what are those people really talking about? How could we explain that light makes us able to produce energy by simply heating some photovoltaic panels? In the next sequence, we will give you the answer to those questions.
In the matter, the electrons are fixed in some energy bands, occupying the lowest energy level first. Depending on the material, the highest level of energy can be at the end or in the middle of a band. In the first case, we have a semiconductor or insulator. Adding a new electron will need to pass through the forbidden band and thus more energy. The second case describes a metal. The new electron will stay in the same band and will just have a very little more energy. The photons of the light, characterized by a specific energy, will interact with the electrons by what we usually call the photoelectric effect. In a semiconductor, if the energy of the photon is greater than the one of the band gap, the electron with the energy of the photon will step up through the forbidden band, creating a hole in the valence band. The pair electron gap will then be relaxed. The electron and the hole will go at the limit of their band by losing energy in heat, but they will not meet each other, being blocked by the forbidden band, unlike in a metal where the hole and the electron recombine and where all the energy is lost in heat. That's why we use semiconductor for photovoltaic cells. There's a part of the energy that's lost in heat, but another part of it can be used as electric energy, the electron and his hole being separated by the gap.
Really interesting report, isn't it?
Yes, indeed.
Now we've understood that famous photovoltaic effect. Let's see how to build those panels used all over the world for producing green energy.
Hello, I present the modeling of a photovoltaic cell in Harris rock. A photovoltaic cell is an electrical device that converts the energy of light directly into electricity by the photovoltaic effect. It's a form of photovoltaic cell which, when exposed to light, can generate and support an electric current without being attached to any external voltage source. The heart of photovoltaic cell is constituted by a semiconductive junction made of silicon. This junction is called a p-n junction. The superior layer is a semiconductor of type N and the inferior layer is a semiconductor of type P. Put in contact, these two semiconductors generate a barrier of potential, which is the base of the permanent electric field. The photons coming from the sun reach the solar cell. They are absorbed by the cell and their energy allows to create an electron pair hole. Through the permanent electric field of the p-n junction, they pass through the solar cell and produce a stream of electrons. This flow of electrons is called electricity. So a solar cell can be represented by a current generator placed in parallel with a diode. Indeed, the generator corresponds to an electron pair hole and the silicon takes the role of the diode.
After my colleague presented the modeling and design of a photovoltaic cell, I'm going to explain you how we apply this theory to the construction of a photovoltaic panel. The main component are of course the photovoltaic cells. Typically, they are made with refined silicon wafers that have been encapsulated between layers of protective materials. Once the cells are made, they are positioned just like this. The parallel positioning together combined with the diodes reduce the loss of efficiency of the cells in case of failure of one of them. A standard panel is composed of around 30 cells. Afterward, the cells are protected with tempered and extra clear glass plate that allow as much as possible photons to pass through without damaging the system in case of breakage. The different components are assembled, for example, with special mastic designed to be durable and effective. Once completed, the solar panels can be integrated in the building in various ways. For example, it can be used directly to build a roof or a bay window.
Thank you. We now know quite a lot about solar energy and how it works, but is it a real necessity for the future? Do we really have to invest that much money in green energy coming from sunlight? Our scientists will give you the answer.
The global energy consumption is alarmingly increasing in recent decades. Nowadays, the consumption reaches 150,000 terawatt-hours per year, which corresponds to the simultaneous use of more than 12 billion microwave ovens. To satisfy these huge needs, we used different sources of energy, but a bigger problem appeared. 80% of currently used energy sources are not renewable or not sustainable. If we look at the solar energy available on Earth, we can see that the sun provides an amount of energy that is 1,000 times greater than what we need. Therefore, photovoltaic technologies are maybe a solution to our problems. Today, the best solar panels have a productivity of 43%. Future prospects of photovoltaic panels are varied. This is an active area in industry and in research. Last year, the photovoltaic sector grew in the world of about 35%. Currently, research are made on the main material, the silicon, but also on non-silicon thin film and in material not yet useful as organic materials.
We need to use this technology even if it's not perfect. We are sure the efficiency of this technology will evolve in the next generation. Humans must invest in photovoltaic.
So this closes our edition about solar energy. You got the message. If we're not all dead tomorrow, invest in green energy setups, and we will all live long and well on our beloved Mother Earth.
Thank you for listening and see you soon on the next edition of Useful News.